All right, yesterday we worked on, if you remember, inequalities in one triangle. Today, what we're going to do is look at how we can write inequalities in two triangles. So when we compare two triangles, what are some of the comparisons that we can make? Okay, so our opening question today is this. All right, let's say the two families set sail on their boats from the same dock, heading to separate vacation destinations. Okay, the Smiths sail 3.5 nautical miles north. They turn 85 degrees east of north and then sail another 2 miles. The Griffins sail 3.5 nautical miles south, turn 95 degrees east of south, and then sail 2 nautical miles. At the conclusion of their vacations, they decide to race back to the original dock. So if they leave at the exact same time and travel at the same speed, who wins the race back? The Smiths or the Griffins? Okay. Using inequalities between two triangles, we can answer this question accurately. Okay, let's get back to that in a second. The main concept for today is the hinge theorem. Okay, so the hinge theorem, I'm going to read this to you and we'll talk our way through it here in a second. It says if two sides of a triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second triangle, then the third side of the first triangle is longer than the third side of the second. Okay, so if you look down here at our example, okay, AB is congruent to JK. You can see the marks through it. Okay, AC is congruent to JL. You can see the double mark through it. Angle A is 45 degrees, which is bigger than angle J, which is 29. Okay, so here's my hinge. This triangle has a hinge. This triangle has a hinge created by the same length sides. Okay, so the hinge is made up of the same length sides. Because this hinge is open wider, the degree is bigger, then the side across from it is larger than this side across from this 29-degree angle. Okay, but you have to have a hinge to be able to, or your hinge has to be made up of congruent sides to make that determination. All right, so we got to look for a hinge made up of congruent sides, and then we can use the angle in that hinge to determine the side length, compare the side lengths of the two third sides of the triangle. All right. We also have a converse of the hinge theorem. And what this does is talks about the triangle. So if two sides of a triangle are congruent to two sides of another, and the third side of the first triangle is longer than the third side of the second triangle, then the included angle of the first is greater than the included angle of the second. All right. So again, let's look here. I got PR and TV are the same length. RQ and RV are the same length. So there's my hinge. This angle and this angle are the hinge. They're made up of the same side lengths. Okay. Across from V, the angle in this hinge is 14. Across from R, which is the angle in this hinge, is 10. Since 14 is bigger than 10, angle V's got to be bigger than angle R. So angle V is greater than angle R. We don't know what the angles are. We just know that this angle is bigger than this angle. All right. So that's the hinge theorem. Okay. Now back to this. So we talked about two families and they're going to race back from their destinations. Well, to understand the question, we got to make a drawing of it. Okay, so let's say both couples are starting at the dock, which is L. Okay, the Smiths are going to go 3.5 nautical miles north. Okay, then they're going to turn 85 degrees east of north. So they're going to turn 85 degrees east of north, and then they're going to travel another 2 miles to their destination N. Okay, the Griffins are going to travel 3.5 nautical miles south, exact opposite direction of the Smiths. They're going to turn 95 degrees east of south and then go 2 nautical miles to theirs. Okay, then they're going to race back from there. So the yellow line, I think that's yellow, is the path they'll take, a straight line path back to where they came from to start with. Okay, now what happens is we get a hinge. So 3.5 miles, 3.5 miles. So this side of the triangles are congruent. 2 miles, 2 miles. So there's our hinge. The exact same lengths are making up these two angles. All right. So what's this interior angle? Well, it's 95. Remember, this is a linear pair, right? Straight line. 85, 95 makes 180. This angle is 85 because they turn 95 degrees. So 85, 95 to 180. Okay, so now based on the hinge theorem, the Griffin's path is 85 degrees. The Smith path has an angle opposite of 95 degrees. So the Smiths have a longer path than the Griffins. Path, I should say, than the Griffins. Okay. This line for the Smith is longer than this line for the Griffins. So by the hinge theorem, the Smiths will have a further distance to travel back to the dock. So barring any unforeseen events, the Griffins should return first. They're going to go same speed, lead at the same time. Their distance is shorter, all based on hinge theorem. Okay. So that's that. Now, what are questions you're going to see tonight? All right, here are some of them. This one is just saying compare the given measures for each by choosing greater. This is less than, greater than, or equal to. If there's not an information, select cannot determine. So what we need to do is find the hinge in here. Okay, so if you look at it, AD and BC are both 6. So we know this side and this side are the same length. BD is congruent to itself. So we have a hinge. This CBD and this ADB, they are made up of sides that are the same length. So there's a hinge. So there's a 56-degree angle and a 42-degree angle. So CD across from the 56 has got to be bigger than AB, which is across from 42. And again, we're just saying which one's bigger or smaller. We're not giving it a length or anything. All right, come over here. Two different drawings. Do we have a hinge? Well, XZ and FG are both 15. FE and YZ are both 12. So there we go. We got a hinge. Same length, same lengths. So now look across from the hinge. Across from Z is 19. Across from F is 17. Since 19 is bigger than 17, Z's angle's got to be bigger than F's angle. Okay? That's using hinge theorem. Another example here. Okay, so you look and it's given to you, right? They're giving you markings. So JK and PR are the same length. KL and QR are the same length. So there's our hinge, right? There's our hinge, there's our hinge. So the side across from the 68 has got to be bigger than the side across from the 66, right? So JL has got to be greater than PQ. Last one, again, find the hinge. So FG and XZ are both 8. FE and YZ are both 6. So there's our hinge. Look across from the hinge, 10 versus 11. Well, angle F's got to be bigger than angle Z because the side across from it's 11, whereas here it's 10. All right, so that's how you're going to use the hinge theorem tonight. Okay, the other thing we're going to do is look at the relationship between angles and sides in two triangles. And these two triangles are going to share a common side. So when comparing angles and sides between two triangles, we need a common side between the triangles to use as our base of comparison. All right, so what we're going to do is we're going to rank the side lengths of each triangle individually, and then we'll combine the two rankings using that common side. Okay, so here we go. Here's the drawing here. Order the side lengths CE, EF, CD, CF, and FD from least to greatest. Okay, now the first thing we need to do is find all the angle measures because we got to use angle measures to rank the sides within each triangle. Okay, so angle CFE, this angle right here, we would get by doing 180 minus 44 plus 73, which is 117, which is 63. Okay, so I know this angle is 63. All right, angle CFD is the complement, or excuse me, the supplement of 63. It's also an exterior angle, which is equal to these two added together, if you remember. So this angle will be 117. And then I know these three angles have to add up to 180. 13 and 117 is 130. So this angle is 50 degrees. So now that I know all their individual angles, I can rank the sides of each triangle. So let's rank triangle DFC, this one first. And they want least to greatest. So what's the smallest side here? It's the one across from the smallest angle. So CF is the smallest, and then DF, and then CD is the biggest. So CD is the biggest, then DF, then CF. Ranked them. Now rank the other triangle. Okay, well, again, least to greatest. So the smallest angle here, or smallest side, excuse me, is across from the smallest angle. So that's FE. FE is the smallest. and then it'll be CE, and then CF. Okay, so we've ranked them each individually. Now we want to put it all together because they ask us to rank all of them. Well, notice in the first triangle, CF is the smallest. And in the other triangle, CF is the biggest. Okay, so if I just kind of join this together, if CF is bigger than these two and CF is smaller than these two, then we know that these are the smallest angles over here. So EF, CF, CE, CF, DF, CD is the correct order. And I'm using the fact that CF's the biggest here and the smallest there to put these two together. Okay, another one like that, just to go through the process with you again. Okay, again, we got to find all the angles first. So what's ABD, or this should say ADB, this angle right here. Well, it's 180 minus 62 minus 78. It's going to be 40. If this angle's 40, this is the supplement, which is 140. And then 140 plus 17, take away 180 is 23. So now that I have the angles for each, I can rank their sides. So ADC, so I'm going this triangle first. The smallest sides across from the smallest angle. So AD is the smallest, and then DC, and then AC is the biggest. And then rank this triangle. Okay, we would have AB is the smallest, and then BD, and then AD is the biggest. And now, if AD is the biggest triangle here, or excuse me, the biggest side here, and the smallest side here, then when we put it together, AB and BD are the smaller sides than AD, and then DC and AC are bigger. Looks like that. Okay, so that's what you're going to work on tonight. You're going to work on hinge theorem, and you're going to work on ranking the sides from two triangles. All right. All right. I'll let you have